Okay, so I'm just going to do one more quick example of functions, and I'm going to introduce the idea of recursion. Okay, so recursion is a particular technique that we can use inside of programming as a way to write an algorithm. Okay, so recursion is very similar to looping, but it's a very specific case. Okay, so I'm going to write out a function that calculates a factorial. So function fact return as my output is equal to factorial of n. Alright, so I'll save this one, save it as factorial.m. Couple of warnings: fact return might be unset, yep, because we haven't written the function yet, and input argument n might be unused, excellent, because we haven't written our function. Excuse me. So to calculate factorial of n, we have just as a little descriptor, factorial n roughly equal to n that, which is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by, I'll just put little brackets around this guy and this guy, dot dot dot, multiplied by 1. Alright, so that's sort of a definition of factorial. So factorial 5 would be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Alright, so we all did factorial as a previous lab exercise. Now what we can do is do this inside of a for loop. So fact return is equal to 1, and for I is equal to n to 1, n minus 1 to 1. So we take steps of minus 1. Fact return is equal to fact return multiplied by I. And of that. So we've got this little function here, and this should work. So I'll save this and try running it. So factorial of 5 gives us 120, exactly what we wanted to. Okay, now the astute students out there might realize that factorial is also a built-in function that does this exact same thing. How do we know that we're running my version? I'm just going to put in a little disp saying my version. Right. I know that MATLAB preferentially uses the local version first, so it uses the local version first before moving on to the inbuilt functions. But just to show this, I'll save that, run it again, and it says my version 5 times. So it's definitely using my version of the function. Now, recursion itself, like up until now we haven't touched recursion. Recursion itself is the technique where a function calls itself. Okay, so another definition of a factorial is factorial n is equal to n exclamation mark, which is equal to n multiplied by n minus 1 exclamation mark. Alright, so 5 factorial would equal 5 multiplied by 4 factorial. Okay, so we can keep doing this going down until we get a factorial of 1. Alright, so factorial 1 is equal to 1, and that's just its definition. There's nothing further than that. So this sort of idea is what's the basis of recursion. So this idea that a function can call itself and solve itself that way. So we're going to implement factorial as a recursive version. So I'm going to comment out all these lines because they might be helpful. Now, to write factorial as a recursive version, we need to handle the bottom case. So at some point, we're going to have to do something different, and for factorial, that's when we're trying to find the factorial of 1. So if n is equal to 1, fact return equals 1. Alright, and so just as this, I'm going to call this function, so factorial 1 returns 1, which is correct, but we aren't handling any other case yet. Alright, so we aren't handling the higher cases. And to do this, else fact return is equal to factorial of n minus 1. Alright, so this is going to call itself whenever n doesn't equal 1. So the first time, like if we're going to call factorial 5, the first time n does not equal 1, so it's going to call this function for 4. So the first time was 5, the second time is going to be 4. 4 comes through, so another instance of this function with its own workspace comes through. We'll also go into this else version and call factorial of 3 and keep doing this until it hits 1, and then that's it returns 1 that comes up. Now I've got a slight bug in this, in that the fact that we return isn't just the factorial of the previous one, it's n multiplied by previous factorial. So I deleted the line, which I probably shouldn't have, that sort of established that. I'll just write it out again. So factorial of n is equal to n factorial, which is equal to n multiplied by n minus 1 factorial. So factorial of n, so this guy, is equal to n multiplied by n minus 1 factorial. So n multiplied by n minus 1 factorial. Alright, so this should now work. I'll save this and type factorial of 5. Alright, and we get 120, which is the right answer. And it's just a different way of writing the same thing. Now, for this particular example, writing it recursively probably isn't hugely beneficial. In fact, it's probably the worst way to handle it, because if we do, say, a really large number, I don't know if 100's big enough, 100 is big enough, to 1,000, maximum recursion limit of 500 reached. We can set that limit, but we are running out of stack space and can crash MATLAB and or your computer. That's bad. We generally don't want to crash our computer. So what happens is, because we've got to generate a new workspace and store these variables so many times, for factorial, doing it recursively, it's one of the easy ones to understand, recursion, but it can be a big problem. Where recursion is really, really helpful is when we're working with tree structure algorithms, and a big part of that is AI, so artificial intelligence. If you're interested in that sort of thing, shoot me an email or start a discussion on the discussion board, and I'll pass you guys some information. This is getting into algorithm design, which is a bit outside of the scope of the subject, but just remember that recursion is a really cool little trick that you can use, and sometimes it's going to be really beneficial. Alright, cool.